Okay, this is James Wang, and this is the gated clock circuit implementation on breadboard, which is constructed on the timer circuit from the previous lab. So switch 1 and switch 2 work together with the quad AND chip to determine the status of the LEDs. So when switch 1 is open, like what it is now, regardless of switch 2, only LED 0 from the timer circuit is flashing, while LED 1 and LED 2 are turned off since there's no current flowing through this part of the circuit. So when switch 1 is on, regardless of switch 2, you see that the output Y of the AND gate will be determined by input B, since input A equals to 1 under this situation. So when the square wave signal from pin 3 of the timer chip is high, which means B equals to 1, LED 2 lights up. And when the square wave signal from pin 3 is low, which means B equals to 0, LED 2 goes out. LED 1 will always be lit up since there's constant current flowing through it. So now when I let go switch 1, you see that the LEDs are back to its original state. So to make this circuit looks cleaner, I took several design techniques. So firstly, I took advantage of the horizontal holes of the breadboard, which are conveniently linked together, so that I can cut the overly long connection into two different components which are linked together through the horizontal holes. And the same technique was applied when a main route was separated into two different branches, like this one, separated into two different branches. Using the connections through the horizontal holes, I could easily direct the branches to different circuitry components with a minimum use of space.